Hello everyone and welcome to this lecture on network science and social networks. I think it's very important before I start the lecture to mention that this is a very large topic. There are many lectures out there. There are even entire courses on social networks. So what we'll be covering today is really the very basics, but if you want to delve into the topic more, then of course you can do so. This is a bit of an overview of how the lecture will be structured. We will talk a bit about the history of psychological network analysis, about network theory and terminology and concepts. Then we will move on to analyzing social network structures, and we will talk about centrality and small worldness. And finally, we will have a bit of a practical kind of session where we will talk about drawing networks using R. All right. Let's get started with the first topic. Okay, so this is a bit of the story of where we come from, which is this idea of conceptualizing psychology as a complex system. And we know that in psychology, there are a lot of processes that are interacting with each other. Of course, we have the psychological processes, but the biology plays a very important role, and also the sociological processes play a very important role. And all of these together just interact with each other in really complex ways. And I would say that in about the past 10 years, there has been a movement away from a reductionist approach. So away from an approach where we kind of try to simplify everything and find the cause for depression or the genes for schizophrenia, towards kind of acknowledging that things are much more complicated and complex than that, and trying to embrace this complexity, and also developing the statistical tools that will allow us to study this complexity. Okay, so this is the main framework in which we study psychopathology and mental disorders for the past very long time. And I think many of you are familiar with this framework, which is called the common cause framework. And the main idea or the main assumption behind this framework is that we have a latent variable or an unobserved variable or a common cause, and that causes symptoms. So in this case, let's take the example of depression. Depression is a common cause, or again, a latent variable, and depression causes symptoms such as insomnia, fatigue, concentration problems, excessive worrying, and so forth. And a very important assumption behind this model is that these symptoms, they hang together because they are caused by the latent variable, because they are caused by depression. And that they are interchangeable, so if we remove depression, then the symptoms will also go away together with the depression. In more recent years, however, the network approach to psychopathology has gained a lot of ground, and the main assumption behind the network approach is that symptoms actually have causal power to influence each other, and that zooming in into the symptoms and moving a bit away from the latent level might give us some new insights. So, for instance, you can imagine that if last night I had a lot of trouble sleeping, that may have led to today being really worried because I'm very tired and I can't focus very well, and that will lead to a lot of concentration problems for me, and that will in turn again lead to being very tired tonight, and also maybe ruminating over everything that has happened during the day. And then when I go back to bed tonight, I'm also not going to be able to sleep once again. And these kind of causal associations between the symptoms actually make a lot of sense, and they also align extremely well with clinical practice and with the way clinicians think about symptoms and disorders. And I think that is one of the main reasons why this approach grew so popular over the years. So within the network approach, we really zoom into the symptoms and focus on the symptoms themselves, rather than assume that we just have some unobserved latent variable that causes these symptoms. More recently, Danny Boersboom actually wrote a very nice paper where he describes in more detail the network theory of mental disorders. So if psychopathology is the topic you're working with or the area of your research, then I would definitely recommend reading the paper, because it also includes and goes beyond symptoms, and also includes some information about how we can think about the external field, so risk factors, genetic factors, how we can sort of build a big theory around this. So yes, if you are interested in learning more about this, I would definitely recommend going further into reading this paper. There are a few consequences when thinking from a network perspective. One of that is that we think about the co-occurrence of symptoms, mood, personality aspects, and so forth as emergent behavior. So everything is emerging in very complex ways, and symptoms interact with each other, with moods, with personality aspects, and so forth. And this can have, of course, certain implications, such as, for instance, symptom-based interventions. So maybe one symptom plays a very important role in the network of depression, and then it might be very important to focus on that one particular symptom. We can also think of every person as having a different system. So it's very likely that the variables that are important for me are quite different than the variables that are important for you. So let's say maybe in my network, exercising is a very important node. And if I spend 3 or 4 weeks without exercising at all, then that will put me in a really bad mood, and that will affect a lot of the variables in my network. While for somebody else, exercising can be replaced with another variable that's very important in their network. And this can have implications such as personalized modeling and treatment. So looking really into studying the network of a person, which I think to some level is actually what a clinician does, right? Because you really focus on what is important and relevant for a person. We can think in terms of attractor states and critical transitions, and this can have important implications for dynamical systems modeling. So if we can build some theory, or we can think about, okay, what is important? How can we build a network? And then we can construct dynamical systems over this. So we can construct, we can use mathematical tools to build theories, and then try to see how for instance, a certain network behaves when an intervention is placed on the network, and where we can tweak parts of the network. And there's a lot of new work done in this field, which I think is very interesting and very promising. And also very nice, we can take a lot of analogies to many other fields, such as ecology, physics, virus spread models, many fields that have already moved towards these complex systems thinking way before psychology did. So we can borrow a bit of information and try to align our questions to their questions. And I'm going to focus a bit more on this in the coming slides. For example, one analogy is to think of every person as sort of a lake in ecology. And in ecology, what happens is that researchers use this idea of mutualism to explain why things co-occur. So they don't say, okay, we have this clean lake and this dirty lake, and this lake is clean because we have a latent variable called lakeness that keeps this lake clean. We have a latent variable, also lakeness, that keeps this lake dirty. But what they do is to explain this phenomenon in terms of mutualism. So the water is clear in the lake because there are plants in the lake. And because there are plants in the lake, then there are fish in the lake. And all these things keep each other constant. And all these things interact with each other and then keep the lake clean. But if something disturbs the system, so for instance, if suddenly there are no longer plants or no longer fish, then that will be a problem. And the system will then be disturbed, and likely it will transition from a clean lake into a dirty lake that's not nice, and there are no longer fish, and the plants are dead, and it's green and smells bad, and so forth. So it's this idea that this is a complex system where everything is keeping each other constant. And we can think, of course, of a person in the same way. So if everything is going really well with me, and I'm happy, and I have a good job, and everything in my personal life is great, then I'm probably going to do well, and I'm going to be happy, and I'm going to be satisfied. But if something disturbs my system, if something bad happens to me, if somebody that I love very much will die, then that will have an influence on my system. And then if I start feeling very sad or distracted, and I'm likely going to perform worse at my job, and then my system will likely move into a very different state and could eventually get into a depressed state. So it's really this idea that there are many complex things that interact with each other. Another analogy that we can think of is of psychopathology as a virus. And this is one of the first things that our lab did. This is simulating a network under a virus spread model. So this is the network of one person, and this person has symptoms. I think in this particular simulation, there are symptoms of depression and anxiety. And whenever a node becomes red, then it means that that symptom is activating. And if you keep your eye on this network, on this side here of this network, you will notice that at some point, something is happening. So you can also think of this network as many people who become infected at one point, and then they have a chance of infecting their neighbors. Okay, so sometimes one node is activating, so that person becomes sick or that symptom activates. But here we see a clusters of nodes activating. And what happens now is that nodes keep activating and more symptoms become active, and they also don't go back into a healthy state. So we had these rows of symptoms that became activated together, and now this person has clearly got into a disorder state where everything is keeping each other constant and all the symptoms become active. And what's really nice about this is that we didn't tell the system to behave in this way. It's just what happened, and it's also really nice because this simulation just shows emergent behavior, which can occur under a very, very basic model like this. It's nice. So these kind of models, they have been studied a lot, especially in social network analysis, where what we're interested in knowing is how the information spreads. And here you can see an example of a network. This is a Facebook network, and it highlights friendship patterns. So this is built out of more than 60 million elements. There's a link that I also included here, where you can read a bit more about this. And this is really difficult both to compute and visualize. So the person who made this network, his name is Paul Butler, and he was interested in answering questions such as how local are our friends and where do you have the highest concentrations of friendships. And what we can see is that the US, this area, is doing, it's very highly connected. So it's you have the highest concentrations of friendship, while if we look at Africa, the concentration of friendships are much lower. So by creating this kind of social network analysis models, then we can get some insight into different patterns of interest. This is a similar network to what we previously saw, and this shows the top 500K Airbnb trips, also across the world. And what I really like about this network, and I think it's really nice, is that this was actually made using R and using a package called Airbnb. I'm not sure if that package still works, but there's a link also that I included here that you can have a look at and play around with. But yeah, I think this is a really nice example also of what kind of visualizations we can do with R and ggplot2, and that we have very powerful tools to study the dynamics that we're interested in. Okay, this is another example. This is from high school students, and this shows the patterns in their dating in a high school. If we look at every node, every circle, we have blue and pink circles. The blue circles are males and pink circles are females. And then the researchers simply asked everybody in the high school, who have you been dated? And then build a network based on that information. And this network has some very interesting properties that we could study. For instance, we can see that some people dated only one person. Right? This person only dated one person here. This person dated only one person here. But we can also see that some other people dated quite a lot of people. So if we look, for instance, at this node here, here in the middle, then we can see that that guy, well, he did pretty well with the ladies. And also, yeah, we have a few more of these kind of nodes that are connected to a lot of other nodes. And we call these hubs. So these are very important nodes in spreading the information, and they're very central and very well connected in the network. And also what's very interesting about this network is that we have this big cluster here. So this is a cluster of people that dated a lot of other people in the high school, but then we also have quite separated clusters of nodes around this very, very big around this very big network by itself. That's also interesting. And this property, having this kind of hubs and very well connected network, but also more other side networks on the sideline, that's very interesting. And this is called a scale-free property. That's because of this hub system, and this kind of hub nodes, they can serve specific purposes on the network. And if you know you have a scale-free network, then you can also do a lot of really cool stuff, and you can do a lot of you can investigate the network in a lot of ways. So yeah, we can look at how the information spreads in a model like this. Okay, so what we saw is that networks, they can be very useful structures in mapping out psychological complexity. However, of course, to study such a network, we first need to construct it. And there are different ways in which we can construct networks in psychology, but this is a bit different than in social network analysis. Because unlike friendships, where we can just kind of point out and see who dated who, or distances, where we can just measure or look at the distances between two cities, in psychology, we cannot really ask depression and anxiety if they hang out together. So what we can do then is to construct these networks in two other ways. One is through dynamical systems modeling. So we use theoretical expertise to form a network from the ground up. So for instance, we could ask a clinician or a patient about their symptoms and then start building a network based on what they report as thinking their network looks like. Or we can use what now has become known as the field of network psychometrics. And this is the network estimation methodology, which has been worked out in the past 5 to 10 years. And while it originated from the network perspective, now it is more often used as an exploratory hypothesis generating method. So once again, I would like to really point out that psychological networks differ from networks of many other disciplines in one very fundamental aspect, and that is at the edges, they are not observed and we need to estimate them. So unlike social network analysis, and unlike this network of dating patterns that we saw before, in psychology, we usually use data, and then we estimate this kind of network structures from data. And that's a very, very important distinction. And also many authors can agree with the network theory. So this idea that symptoms are active causal agents and that every person has a different system, I think that aligns very well with how we think about psychology and psychopathology, and a lot of people can agree with this. But if you agree with or believe in the network theory, this can be disjoint from network psychometrics. So believing that symptoms influence each other does not equal believing that an Ising model is what underlies the data. Those are very two different things. I think that's really important also to keep in mind. Okay, network psychometrics, it's a really, really big field, and it has been now applied. Network models have been constructed and applied to many fields, ranging from comorbidity to post-traumatic stress disorder, substance abuse, depression, psychosis, and many more other fields, intelligence, personality, and so forth. So these models, they grew really popular, and they have been applied across a really wide range and area of fields. And I'm going to very briefly touch upon a few examples, but I'm not going to spend too much time on this. Under every example, I included a reference. So if you find the topic interesting, or if it's aligned with your research interests, you can, of course, look at the reference and read the paper. This is an example of substance abuse networks. This is from work by Remtula and colleagues in 2016. So what they were interested in doing here was to look at the network of symptoms of substance abuse across using different kinds of substances. So here we have cannabis, stimulants, opioids, cocaine, sedatives, and so forth. And then what they were interested in is, do symptoms associate in similar ways for people who use different kinds of substances, or would their network look quite different? And if we look at this association between node D2 and D5, we can see that this association is quite different across different substances. So in the case of opioids, this association, this is between withdrawal and monopolizes time. This association is really strong here, while actually in this case it's not present. So this is another example from a paper by Isvoranu and colleagues in 2015, where they were interested in bereavement and how loss affects a network of depression symptoms. So here they asked spouses who lost their loved one about their depression symptoms, and then they included loss as a variable in the network. And what they found was that loss, so losing your loved one, is mostly associated with loneliness, very strongly associated with loneliness. And it looks like from there on, the network of depression symptoms activates. That's very interesting in terms of what could maybe be target nodes for treating symptoms in the case of bereavement. So here it might be that loneliness is very important to target early on. This is an example from one of our papers in 2016, where we were interested in interrelations between environmental exposure and symptomatology. So here, these variables are variables of environmental exposure. So we have urbanicity, cannabis use, and trauma. And we are interested how these associate with psychopathology, symptoms, and also with psychosis expression. And what we saw was that risk factors seem to relate to symptoms differently. So trauma is associated with psychosis expression, while cannabis use was mostly associated with anxiety and depression, and urbanicity was mostly associated with cannabis use. So this is another way in which we can use these tools and network models to look at also associations between environmental exposure and symptomatology. We have other examples from PTSD, so symptoms of PTSD and associations between these symptoms. There's quite some work on comorbidity, and Isvoranu again has a very nice paper, a very nice review about mental disorders as networks of problems. So if you're interested more in the field of psychopathology and what has been done in psychopathology using network models, this is a very nice read. But their network models have been applied to so much more than psychopathology. So I would really like to encourage everybody to think about their own field and how this relates to their own field, of course. So Giulio Constantini, for instance, his entire PhD was on personality and the network perspective on personality psychopathology. So that's very nice work done on that. Han van der Maas, who works in our department as well, he did a lot of work on intelligence and mutualism in intelligence, and that's also really nice. There's been work done in attachment, and more recently, These kind of models, they have even been used to look at different models for patrol and detection dogs. So that's also, this goes way beyond psychology at the moment, and that's really fun. Okay, and this is the end of the first video. I'll see you in the next video.